righty, well, welcome, Anjali, Adri, Tom. Thank you for joining us here on the panel. And again, this is about Data Lakehouse as a new architectural approach. What we'd like to do, well, first off, I'd like to go through all the panelists, and if you could please give us a brief overview of what kind of work you've been doing and you know where your interests bear in on this. Audrey, could you lead off?
Certainly. Thank you, Paco. So I work for Group Risk within BNP, help all the brands and subsidiaries for AI governance and risk, and also essentially data strategy. And the work touches privacy, architecture, platform, and AI implementation.
Good morning. Thank you so much for having me. Very excited to be here. I work with Salesforce. I am part of a team called Data Science Applications, whose main goal is to develop machine learning applications for our internal stakeholders to help them make better decisions. So those decisions could be around making our customers more successful, or around driving product strategy, around optimizing product decisions, things like that. We typically build predictive models, mostly time series models, that enable us to have this view over time to see how things are evolving and make predictions about where things are going to be headed.
Tom Nats. I'm Director of Solutions here at Starburst. Been here a couple of years. Been doing data warehousing and ETL and stuff like that for many years. And at Starburst here, I'm excited about the technology that we have, and going back from just building a single data warehouse and you only had a couple different options to now we have almost hundreds of different options for storage and analytics and that type of stuff. So just trying to help our customers try to figure out where they want to put their data and how to query it. So.
Wonderful. Thank you very much. Alrighty, I'd like to give just a brief overview of the architectural pattern, the kind of concepts that we'll be discussing here. So if you haven't seen about Data Lakehouse previously, let's see here. If you haven't seen about that previously, the gist is to be able to combine elements of data warehouse along with elements of data lake, and to have, if you will, a simplified architecture that attempts to leverage the best of both. So, certainly going back into the late 80s and all throughout the 90s, there was this huge burst of a lot of work with data warehouses, and there's a lot of practice in terms of data management, governance, schema overlay and evolution of schema. Just in general, your data organization practices are very well defined over on the warehouse side, and a lot of analytics stack, of course, too. In the data lake, though, you have more contemporary terms of leveraging cloud resources, for instance, or hybrid cloud resources. So this notion of separation of storage and compute ends up being a very large factor when you're working with data management at scale. And also, beyond the point of like cost optimizations like that, with data lake approaches, typically we're working with a variety of different types of data. Some of it may be semi-structured or unstructured. So you could have log files, you could have images, etc. And typically there's a lot of open source projects that are available for leveraging more of the unstructured data, obviously in data science, whether you're doing computer vision with deep learning, say with PyTorch, whether you're working with different time series tools, something like Prophet. There's a lot that's available over on the data lake side. So really the question is, how can we integrate the best of both and provide better coupling with data science practices and machine learning tooling? Now, there are definitely some pros and cons, and I'm looking forward to discussing that more throughout here with our panel and also audience questions. But just kind of the high points, certainly there are some considerations here. Number one, can we reduce redundancy of data and also stagnation in the sense of, instead of having data siloed out that's not being managed under consistent practices? Can we avoid some of the stagnation issues and just optimize it better? Certainly there's matters of data governance in general, and that's a much larger topic we'll dig into a bit later on, but can we address some of the overhead, the operational costs for whatever our data governance practices are? And of course, that's going to change between different verticals, but overall, this type of architectural approach may be able to provide that. And then in terms of considerations on the other side, Data Lakehouse is still arguably somewhat of a monolithic architecture. So if the idea is that you abandon all of the strategies and move everything into one strategy, yes, of course, that'd be a monolith. In practice, that probably never happens. There are certainly considerations that relational models don't do everything. They do a lot very well, but there are certainly some types of algorithmic work, some types of machine learning work that just doesn't really fit well in areas of business applications that are needed. And for instance, that gets into areas of doing graph traversals, doing uncertainty representation, and others. Relational may not be one size fits all. And the other consideration too is just like, how much of an improvement does this make over current practices by introducing this type of architecture? What kind of trade-offs are we making? What kind of benefits are we gaining? Is it something that's a large return on investment, or is it just incremental? In which case, why go to the effort? That's something I'll put out as more of a question for the panel. And then thirdly, I think this dovetails in really well with what Dane and David were talking about in the previous panel. I mean, we really do struggle with physics at some scale. When we're talking about really large-scale data transfer requirements, we can run into bandwidth bottlenecks. We might make a simple change on the efficiency of processing and what we're doing on CPU utilization, and then suddenly we're soaked on bandwidth. So, this kind of technology, you do want to understand where the performance issues are and how things are being tuned. And this is a great space to be working in it too. And with those caveats, I should mention that I am here as a moderator. I'm not here as a proponent of any particular architecture. I'm here for objective discussion about it. So just to clarify that, frankly, I tend to work in a different area of the stack a lot, where sometimes maybe this kind of architecture is not as indicated, but I really want to hear an objective discussion about it. There's a couple other things too that when we're talking about federated queries, that transitions into arguments about do we use Lakehouse architecture in combination with other patterns, data mesh, for instance, and we'll be talking much more about that later today at Data Nova. Really looking forward to that. I think that there's a great quote from Helena Schwenk. The strategy for data democratization is coexistence, and certainly in enterprise, it's something that we have to worry about a lot. All right, just to wrap this up, if you want to look at some primary sources, we tried to link these in. I believe these slides will be available to the public, but this is sort of a decade by decade look at when a lot of the main innovations in data management were introduced, 60s and 70s, going into the 80s. We've got big data since the 2010s, obviously. This notion of Data Lakehouse came out of late 2017. So we've been working with this for approximately almost 4 years. And I'll just throw in a couple other primary sources, certainly in terms of separation of storage and compute, this notion of where is cloud evolving and where are the economics going. I'll point to Jan Strojka, Eric Jonas, and all from Rise Lab at Berkeley ECS. They have Cloud Programming Simplified as a paper that came out 2 years ago that's just really brilliant in that area. And for what it's worth, there's also an overview of history of data management over the past 50 years or so that I've done. So with that, let's jump into the first topics, and I can take this off the screen. But first off, I want to just introduce, so Anjali, Adri, Tom, actually, let's go in order. So Ajay, start out. What are your perspectives about data lakehouse architecture, and what are some key points for decision makers to be able to understand from your experience about what this kind of infrastructure supports?
Thank you, Paco. I see there are a couple of forces that are leading to architectural pattern like Lakehouse. One of which is the heterogeneity among tools. You have data scientists, data engineers, data analysts. You've got even data analytics translator, and that heterogeneity of skill set and also the jobs to be done is leading to sprawl of data tools. Data Lakehouse, if it delivers the ambition or any other architecture, the key point is to reduce operational complexity and hence, on the other hand, reduce any of the operational headache from data governance, data security, data protection that comes into play. The other one is around it's not only cost reduction, the ability to essentially get people data together. It doesn't need to be centralized, but a homogeneity across the strategic imperative where you have unstructured data, which is increasing a lot in usage. And then you've got structured data, which has been traditionally supported by data warehouse architecture. That veracity of the type of data sets with the intention to perform machine learning or advanced analytics on them leads to such architecture conducive to that. Again, more you go away from the domain and the point you mentioned about data mesh, there is interpretation issues. However, I think there is the key leading indicator is the intention to use more advanced analytics, and you can't really do it with just data warehouse. You can probably pursue semi-structured data if you want to classify it as it, but I feel that those are the key drivers.
Fantastic, thank you. Anjali, I'm eager to hear your perspectives.
Yeah, I think, a lot of what Adri said really resonates. I think as a data scientist, some of the strong kind of draws of a data lakehouse for me are things like, reducing time to value or time to insight, because data scientists have much easier access to a whole host of different kinds of data, which in a warehouse kind of setup is not as easy. So right now, to realize a lot of value out of your data science investments, you really need to have that edge in terms of the data and the insights you generate. And that more often than not will come from alternative data sources. And these typically tend to be unstructured data. So from that perspective, I think the Lakehouse architecture is very attractive to me as a data scientist. But there are definitely some caveats and things to be mindful of. So I think in terms of implementation and adoption, I think there are definite challenges. One of them, and a really important one, is around the skill sets and legacy processes that already exist within data science teams. So data scientist is such a broad kind of a job description, and there is a full spectrum of skills. So on one end, you have very technical teams that have both very strong engineering and machine learning skills. And then at the other end of the spectrum, there are data scientists who are mostly using SQL, and it makes it very challenging to migrate those kinds of teams to an architecture like this, where the emphasis might be on using more technical languages. So I think there's definite challenges. I think the other one that is really important is with a data lakehouse, the assumption is that there is a really great metadata and contextual data around what exists in your lake. I think for data scientists to be able to leverage and like Adri said, really deliver on its promise, you need that contextual information, and that is again not an architectural issue, but more around processes and practices that exist within the teams. And I think that to really get that to really reap the benefits of a lakehouse, all of these things definitely need to be considered.
Fantastic. Thank you. Tom, love to hear your perspectives, experiences using this.
Yeah, thanks. I think a good history lesson is always in order for this, and unfortunately, I've kind of lived through a lot of this in my past. Is when I was I went to work for Comcast as a contractor, and we brought up their Hadoop cluster from scratch. We started with like 10 nodes, and it was really the use case was to bring in streaming data from viewing boxes, from the set-top boxes. It's something that they've tried like 3 times before and failed with a typical data warehouse, and it was probably Teradata or Oracle at the time. It was just too much data. And so that use case became, now let's put more data in the lake, And then they tried to apply typical EDW kind of patterns to this. They had like the data modeler sit there and try to model stuff, and people are just dropping stuff into this lake left and right. And it became completely out of control. And then you still had the warehouse sitting over here. And then how do these two work together? And then over time, it came to be where you didn't have security, you didn't have governance, you didn't have anything. It was just like this wide open lake. And then people decided, well, we'll have a bunch of stage data in our EDW that we're spending money just storing. Let's start to put all the data in the lake first. And then from there, we can figure out what data needs to go in the warehouse. And that's the world we live in right now, is a lot of these companies have both. And they're trying to figure out now, how can I save money instead of putting more and more data into my data warehouse? What workloads can I just run out of my data lake? And then that's why our technology is kind of increasing in use, is because we do have data in both places. But now companies are going, okay, what features can we add to a lakehouse so I don't have to move this data out? Can I aggregate it, summarize it? What about, write once, read many type workloads? Those can now stay within the lake. And then we're starting to add more DML, which is update, insert, delete, especially for GDPR, that really pushed it. How do I update data in the data lake? That was always a pain. We had to override entire tables just to make changes to tables. So that's now we have Delta Lake, we have Iceberg from that Netflix open source. So we have these storage technologies that are now available. So we're bringing more and more functionality, and security is now coming into play in the lake. So we're adding more and more these database features that were very important to EDW that we took granted for many years. Those are now being added to the lake. So now we're getting closer and closer, which is pretty exciting for me. I'm not really a big monolithic kind of person, because I've lived through that. It's very, very difficult to shove everything into one place. But data does need to reside somewhere. So either in a source system or in these different data marts out there. But with the Lakehouse, now we're getting more and more features to it. So this could be closer than we think it is. So
very good. Very good. Thank you. Anjali, I'd like to drill down. You were talking about some of the contextual information available, not so much architecture, but really more of the people process and how people consume. So I think that's a really good segue into the second topic that we had about, where this kind of architectural approach supports the teams that are responsible for developing insights and data products. Could you describe a bit more about, from a data science perspective, data science team perspective, how you're leveraging this? You mentioned about metadata, context, and others.
Yeah, I mean, that's a really tricky one. So, from a use case perspective and data science perspective in particular, I see sort of two different use cases, if you will. So one is your business as usual tasks, models that are mature, that are in production, and it's a case of updating them on a regular cadence, be that weekly, monthly, daily. And for I think those kinds of use cases, the Lakehouse maybe doesn't change a great deal, because those use cases will still continue to leverage maybe the warehouse portion of things. And I think, as you mentioned in the introduction, right now, the most organizations that are using lakehouses still use them alongside existing data warehouses and data lakes. So I think for those kinds of use cases, nothing really changes much. I think where the real value and sort of the interesting things are happening are on the experimental side of data science and machine learning. So with a lot of the new use cases where it's a lot of trial and error, there's fast iterations, you're building a lot of MVPs and putting them into production to see how they're performing in the wild, as it were. I think that's where a lot of the interesting stuff happens. But like I said, that contextual data and the metadata is really the key to being able to leverage that data in a meaningful way. I oftentimes still see either data being used incorrectly because you make assumptions as data scientists. You make assumptions on what this data means based on your limited purview of how the data came to be, and documentation can often be stale. It can be hard to come by, and organizations are ingesting data at such a rapid rate that they're not able to keep up with, making sure that the metadata and the contextual data is up to date. Data stewardship is another issue. So I think, these are all things that pose very real challenges. And at best, you might not leverage all the data that you have, but in some pretty scary scenarios, I've seen data being used incorrectly and leading to poor decisions. And that really flies in the face of what data science is supposed to enable decision makers to do. So I think that's a really, really tricky one to address. And that's very much about people and processes rather than the architecture itself. I think even a data lake may have delivered on some of its promises if some of these issues had been resolved. Of course, the whole kind of set of issues around the security and transactional transactions and all of those things, those shortcomings would still exist. But I think we would have gotten a lot more value out of data lakes had some of these issues around processes been addressed.
Interesting. Yeah, so you see this almost like this feedback loop of where a lot of the organizational issues, the people issues of using data are brought to bear in terms of evolving patterns for enterprise use of data. Very interesting. Adri, I'll turn over to you. How about your experiences of supporting analytics teams? How's this fare?
So thank you, Paco. What I've noticed, and I agree to Anjali's point, is the most of the use cases, if I look into the entire topology of the group and also in the past, are now leveraging data sources that wouldn't have been even considered in the past. We wouldn't have, let's say, analyzed email data, for example, to essentially for operational excellence or effectiveness. And now that's leading to considering an architecture or data access pattern which is being driven by data scientists, and that's leading to veracity in the type of analytics they are doing. However, on the contrary, what I've noticed is there hasn't been traditionally consideration on how do you enable those workloads where you have compute and storage together in a way where you've got essentially acceleration on the storage front, and you can push compute close by storage. Most of the access pattern still is there is a bottleneck whereby data is read in from some source, then you essentially store it in a sink and then you process it. But I imagine Lakehouse architectures enables the not the separation of duty, but the velocity with which data scientists and data engineers can collaborate, whereby some of the work that was traditionally done by data engineers are now being picked up by data scientists, and which is good in a way, as there is less shared context in some cases where it is cumbersome and it's challenging to have. However, on the contrary, I noticed that there is modality of use cases which are you've got data that is streaming in some cases. In some cases, you don't need high latency decision making. So for that, you either have a siloed approach from an infrastructure standpoint, or I have been observing the demand from data science teams across the group, whereby they want something which enables them to get to essentially some sort of decision making quicker, and essentially less engineering effort, less and from an IT security standpoint, it enables the security teams to consolidate some of the governance, privacy, and security, data security policies and principles through automation, which would have been very difficult if you have some analytics on the side, some data stored somewhere else. You've got an intermediate sink and source. So I see those are the drivers, very much driven by data scientists, machine learning engineers who are very use case driven by business, and business requires it now.
Excellent, thank you. So Anjali and Adri, both putting that together, I mean, a common theme I'm hearing is that from a business use case, time to market is a really important metric from a business use case for data. And engineering can be one of the big costs that drives down time to market. So this is effectively making a shift between where is that engineering happening, how much does it become a hurdle before you can complete a new task. And Tom, with that, I've queued you up. How does this support in different contexts, the analytics missions, the business use cases?
Yeah, I think, there's two things that stick out to me, especially I'm not a data scientist, right? But I've talked to a lot of our customers, and the two things they ask for is, how can I make sure that the data, I don't have to move data, right? So usually they love the data lake because it has a lot of the newer data, streaming data, but they also need to mix that up with, join that with like customer data, typical CRM or ERP type data. So how do they do that? Can we just make sure that's being replicated into the lake, or how can we reach out and grab that data? And the second thing that I hear a lot actually is just sandboxes. Data scientists love to take data and then join a bunch of it together and create little sandbox areas, and then run experiments on them, run models on there, and then maybe switch it around, add different data or external data like weather and that type of stuff. So those are the kind of things that I've seen a lot, is being able to have a sandbox area, being able to reach out to all this data and then build these little models so they can kind of do whatever they want. Obviously, the data's got to be, go through data quality, it's got to go through governance and make sure it's clean data. But I think that's what I keep hearing from our customers.
I'm curious about, I have definitely seen use cases for needing sort of sandbox on demand. What kind of practices are you seeing with customers where, say, I am doing a project and now I've got some derivative data, how can I put this back into the Data Lakehouse? Once I've done my work in my sandbox, how can I go through the steps of getting this back into making it so that other people can use it?
Yeah, I dealt with a company, you probably heard of it, called Expedia, and this is years ago. This is probably 4 or 5 years ago, and they had this almost like, Apache has this board, and they take new projects and put it into the Apache organization. They had the same thing there. Like, if you came up with a cool data set or a cool way you were doing stuff, you would actually document it up, and you would have this data set, and then you would kind of present it in front of this board, and then it would be basically ingested, and it was kind of like a data as a service for the entire company. Now it would be your data, whatever you created was out there. And I think that was kind of interesting. It allows people to create really cool things and then get the recognition and basically present that. And now that becomes part of like your data product or data platform.
Interesting. So for data products, then almost like a pull request with a code review.
Yeah, it was just like that. It was actually really cool. I thought that was a neat way of going about doing stuff.
Interesting. Oh, very good. Thank you. Well, let's dig into a bit more about some of the regulatory considerations. And I mean, we have talked about the people side of using data, but where are some of the cost trade-offs of staying in compliance, following security practices, maintaining data privacy, et cetera? How does the introduction of Lakehouse have impact on, say, the costs and the compliance? And Adri, I'll start out with you on that.
Yeah, so Paco, very good question. I think if Lakehouse has to deliver to the enterprise ambition, and reduces the operational complexity, organizational complexity. On the other side, it enables to some extent automation, where policy enforcement is through code. When I say policy, not for code policy, it's policy for governance, trust in data, compliance. Even if you're doing privacy preserving analytics, for example, or anonymization, you can orchestrate that through code. And the empowerment and enablement does manifest when you've got, to some extent, a central platform where your people and your data stakeholders meet. So that's good. On the other hand, as you know, the regulatory framework for certain industries is definitely changing and emerging, and you've got essentially the requirement to have data residence, where the data is residing, through to data retention and minimization. I imagine that Lakehouse architecture does help. However, there is a shift which I've been noticing towards pushing some of the responsibilities from a centralized to a federated model. I'm yet to be convinced that in that world, a Lakehouse architecture as a monolith will suffice. So maybe we need to either have more automation towards policies, which is not the case. Most of the policies are documents, Word documents, Excel files, and with machine learning, where you have not only code that you have to manage and maintain, you have to maintain and manage data. It is yet to see how that architecture paradigm plays out, where you've got code, data as the sprawl in combination.
Interesting, and I want to ask also, is with the kinds of use cases and business units you're working with, is there a specific GRC team that's handling these compliance issues, or is that still part of what operations is responsible for?
Oh, there are multiple GRC teams. So how we absolutely how we are structured is I think most financial institutions are structured like this. You've got line 1, line 2, and line 3. Second line is risk. That means our team looks into all areas of technology cyber risk, of which data AI is one, quite a horizontal capability. And then if you have something like Schrems 2, GDPR, CCPA, we get involved with the data protection office or data privacy network on enabling best practices, essentially strategies and implementation. But to your point, the GRC systems that are there are, in my opinion, very retrospective. They are not built for the changes and the veracity that is required for a data science enabled world. I truly believe that the GRC platform are more focused on IT tickets in a simple way, or they're not built for code management, model management, metadata management, even data sheet, model sheets. They're not built for that world. So there's a gap, and that's what we are trying to fill. And it's an organizational change as well. You have to really change not the technology ecosystem, but how people, our colleagues, and including me, thinks. How you move from this.
So we need to iterate on that part of the pattern in practice more, but yeah, to be seen still. Yeah. Anjali, how about your experiences on, again, this question of privacy, compliance, security versus the cost? Does Lakehouse have impact on that?
Yeah, that's a really interesting one, because I think one of the things that we haven't touched upon in a lot of detail is that data integration aspect of things. And so in a data lake or a lake house, you have all these disparate data sources, which in and by themselves may not mean much. So if there is a breach or something, then you might be okay. But a lot of the work that we as data scientists do is in connecting these data sources together to then generate those insights that give the organization an edge over the competition. And a lot of that data will go back into the lake or the lake house. And that's where a lot of the security and privacy sort of issues become very murky. I think, as Adri mentioned, I think it requires a whole mindset shift in the way organizations approach data privacy and security, especially with regards to machine learning. So in a situation where the compliance teams aren't even aware of or fully understand what data is going back into the lake internally, that can pose real security risks. And in my experience, a lot of these practices are still very immature, because it's almost like a lot of the compliance teams are still kind of operating in a much older world, and data science and machine learning it is moving at a phenomenal pace. So I can't blame them either. I think, as Adri mentioned, what is really needed is a machine learning or an automation layer on top to kind of understand what the privacy concerns should be, and doing it in an automated way rather than the manual way as it happens right now. So there are costs, sort of in a lot of different ways. If there is a security breach, then I think there is a definite cost, both financial and reputational, that's associated with that. There is a cost associated with implementing state-of-the-art security and security systems. I think there is a cost associated with that mindset shift at an organizational level. I think the other one that's really interesting, especially with regards to GDPR, is people now have the right to request the data that you might have on them. And again, if you don't really have a good system in place that enables you to link a lot of these different data sources and have some kind of an internal data catalog, and that whole metadata around what information you have on somebody, not just in disparate sources, but when they're integrated, and then the insights that are generated off of that, you can easily fall foul of some of these regulations.
Fantastic, thank you. Tom, I will ask also from your perspective about cost versus compliance, what you've seen in that kind of trade-off with respect to the Data Lakehouse.
Yeah, I think it's like back in the old days, right? We had a database and you had a data dictionary, so you couldn't just go put files in a database. You'd actually have to create a table. Once you create a table, that's now in the dictionary, so you couldn't really hide things. We could go find out, what's this table. Now, when Hadoop came along, it was the separation of compute and storage, basically. And S3 kind of led the way with it, with Amazon. And what's nice is you do have that separation. So there's a lot of benefits of that separation, but it's also almost a security nightmare because people are just putting files out there. So on my other tab here, I've got data on 123 million US households exposed due to misconfigured AWS S3 bucket. And it was only 36 gig worth of data. And just to show you that, the separation is great. And if you look at a typical lakehouse, you do have that separation. You have files that are out there, and it's not like files in a database. These are just like Parquet or Oracle, or it could be JSON, it could be something like that. So I think what happened was everybody rushed into the Hadoop world, everybody rushed into the data lake world, and then security was lagging behind, talking years, not like a month behind. It was years behind. It's finally starting to catch up. But I think that was the thing about it, is it's a cheap system to put all our data in, but we just kind of threw all the security out the window. And that was frustrating for me because I saw this coming, like you would create hide tables, and my old places I used to work, there would just be files out there and nobody knew what they were, because you'd have to try to go look in that data if it didn't make any sense to you. So I think we got away from that, and now we're kind of pulling it back together to where we do. The Lakehouse is coming where there is security on top of that, just like all the other systems out there.
Fantastic. And that's actually a really good transition. Tom, let me start out with you as far as the next topic we wanted to cover was how to blend the old and new. How do we introduce new architectures in light of the fact that we have these older systems, and how do we make the practices align? In particular for Data Lakehouse, what are some implications there?
Yeah, I think that's like what we've been, I've been telling customers is look at the other way around. It's you are majority of these customers we're talking to, and they are bringing a lot of the data into the lake first. And then from there, that's now become like the base for a lot of these large organizations we're dealing with. And then there's data marts being built in completely separate systems out there, and they're usually being fed from a data lake. So the idea is, okay, what do those systems have that you can't just leave it in the data lake? Can we bring more features to the data lake so the data doesn't have to be moved around? Can we add more compliance and governance on top of that? So I think that's what we're seeing with companies is they jumped into the cloud or whatever it is, and they're trying to say, okay, how can I control my data? And then how do I reduce my cost? I think that's the biggest thing that we're seeing right now.
So is that in the sense of like machine data that's coming in? You could almost think of the data lake as being the first place that it hits.
Yeah.
Does that become the system of record for it then?
It is actually, and now we're starting to see like ERP systems, and the typical ETL is now and this is years ago, right? It had to became now the raw and the staging layer, and then from there, which was kind of weird to me, but and then you would push that downstream. Now the warehouse is now downstream. The warehouse used to be the first downstream system. Now it's the second or third downstream system that we're seeing. So we're seeing companies like now we have this data sprawl that's out there. We have legacy systems. How can we possibly not? How can we prevent that and bring hopefully more features into the lakehouse? So.
Okay, fantastic. That's an important, especially seeing the staging. Where does the warehouse function actually live? It could be a few stages down. That's so important to bring out. Anjali, how about that from your perspectives? How do you blend the old with the new? And what are the considerations for Data Lakehouse in that context? Sorry.
I think I was on mute. I think there's definitely this kind of blending of the old and new paradigms. I think the two definitely coexist, and the way I've seen it in practice is, as Tom mentioned, your data lake becomes your raw data repository, and then you still have a warehouse as a downstream application. And right now, the old and new definitely coexist, and I think that is what is needed for us to reap a lot of the value out of the new architecture. But I think as new features are being introduced, it becomes easier to sort of transition out of the older systems into the new ones. I think it's the big thing is sort of having those features and then also starting out small. That's the other one that I tend to see. So I think it's usually individual teams or smaller orgs within a larger org who will push for using some of these newer technologies, and then as they demonstrate the benefits and cost savings of it, it tends to proliferate more widely within the organization. I think that's the way I'm seeing things evolve.
Interesting, and that also fits with a lot of what's coming out, or at least from my interpretation, a lot of the dialogue that's coming out from the data mesh community. I mean, you do see these innovations being driven by teams, and they probably are very strongly correlated with, the services associated with those teams, and that kind of reflection between data mesh and service mesh, where data mesh came from. Very good. Adri, how about your perspectives in terms of blending the old and the new?
Thank you. It's actually interesting. Let's go 10 years later, and I imagine in the world where we have currently operational systems, you call it SaaS applications, which are mostly workflow and systems of record. Those are going to become systems of intelligence, and then you have two or three modalities. One is let's push machine learning into data warehouse, and there are some vendors that are doing that, in SQL, within SQL. And then the other is let's essentially put SQL into Python, or essentially in functional or procedural code. And then the third one is how do you get those systems to talk to each other? So the integration, where you have maybe domain-based distributed teams managing the full life cycle of data, and the data product is on top of the platform, which can be data mesh, or which can be built on top of something like data warehouse or lakehouse. But I imagine that the plurality will be essentially the completion of the continuity, where you've got machine learning being pushed into operational system to make decision making autonomously. That's not yet there. You see very few systems where we believe the predictions are so good that decisions are being made autonomously in operational system. But that's where we are going. And from the downstream standpoint, you can see ETL tools. I mean, I spent 10 years back doing less analytics and building more ETL pipelines. You've got so many tools now. You can really just pay and you can get data in one place. But then once you've done that, what is reverse ETL? And reverse ETL, why would you do it? To essentially push intelligence to the operational system. I see it's going there, but I believe the better strategy is to have, as Anjali and Tom said, towards domains. It's very difficult to pick up a domain for a data scientist quite frequently. It's cumbersome. So if you can give the tools to the domain leads and owners, it's probably better from architecture standpoint. Yeah, that's the 10 years from now or 5 years from now.
Oh, very good. I like the term systems of intelligence.
It's stolen. It's actually, I think I came across this. I like it as well.
Very good. And also reverse ETLs, a lot of what we've been talking about. I mean, it's a very thorny issue of we're doing advanced work with machine learning, but then how does it go back in? And I believe that Anjali brought this out, especially and Tom also in some of the cases. A lot of the governance of reverse ETL is probably more complicated than our governance policies can describe. Well, okay, I would like to open up to questions, but we do have one question already from Samir. Samir Pico was asking about, well, I mean, general concerns here about one-size-fits-all kinds of recipes. It seems that many of us are looking for a standard recipe for how to deal with data. One-size-fits-all is difficult. And I think innovation and agility is key for success with data. However, my question would be whether you believe a kind of standardization in the data world would help to lift the data business, is the quote, but I guess practices to higher levels or better efficiencies, more effectiveness. So are there needs for standardization in terms of how we work with data? Will that help or hurt? And I'll go around the room. Anjali, I'll ask you first.
Just to clarify, standardization around the actual data that gets ingested into these lakes or lake houses. Yeah.
So.
Yeah, I think there definitely needs to be that at an organization level, but I think it's a really challenging one just from a data science perspective. So I think how you standardize the data across different domains. If I think of an organization like Salesforce, that standardization looks very different for different stakeholders, and I think that's where the challenge is. The standardization will vary based on stakeholders and use cases. And I think a standardization that works for one group of stakeholders or a set of use cases may not necessarily work for a different one. So I think that's where we run into some of the challenges. But that's not to say that we shouldn't aim for it. I think again, really good documentation, really good stewardship and data ownership within teams. I think that helps a lot. Knowing who you can tap into to get the additional context or learn the nuances around the standardization, what decisions were made, why they were made, and really involving people and being able to reach out to the right people at different stages of that standardization and data processing. I think that is certainly very helpful. But yes, sort of in summary, standardization is needed, but it's a very challenging one to implement.
I really like what you're saying as far as like bringing it back to the individual teams, the line of business units, to understand their context, their meanings. and sort of, again, kind of federating it out to the different business units, because it's going to be impossible to have standardization aligned across all business units. That fits well with data mesh, I believe. Tom, I'll throw this to you then. How about the question of, does standardization in data practices, does it help us? Is it buying us much?
Absolutely. I mean, I keep going back with my age, right? But at Teradata and IBM, we used to have these industry data models, and they were like healthcare, finance. And usually what you do is in a large organization, when you start to build your EDW, you would buy one of these. They were not cheap, right? They were more than $5, but you would get all these different subject areas, and then you would just pick some of these out. And it was a big pain. Yeah, it was probably, you could probably do a lot of this stuff yourself, but it was a blueprint. And so a lot of these large companies were using the same blueprint. So you knew you could go from company to company, like healthcare company. And usually you would have the same tables, the same data models, and that kind of stuff. So that was really, really helpful. But a lot of that, I remember at this large phone company in Colorado, we were like 11 months into our EDW build, and we barely even had data into the stage layer. And then Verizon was one of the companies that was actually buying data. They said, just give us the stage data. We just want the data. We're not going to wait 11 months. So there's got to be a way to do standardization out there for some of these industries, but then kind of get out of the way and let us be agile, let us move, because then you're going to get back into where it takes 5 months to get a new data source online so you can query it. And that's where we're at. That's why the data lake and everything came out in the first place. So.
Yeah, very, very well said. I mean, there is that trade-off between how strict your semantics are versus just how agile you can be with use cases. Adri, what are your perspectives on this?
I agree totally, Paco. I think one of the important things, instead of, or probably in addition to standardization where it is right. So for example, in the space of external data, alternative data for finance, there is FISD, which is looking into standardization. I imagine the enterprise architecture should be built around open interfaces where you have the modalities of the data domain and business domain to be able to model as fit to purpose, essentially interchanges. And Apache Arrow, I think, is going to a good direction in that way from an open source standpoint, if you're aware of that. So I think interfaces where data exchange is facilitated is probably a good decision to move towards.
Oh, excellent. Yeah, I was actually writing some code with Arrow this morning. Very, very good to hear that. It's one of my favorite projects. Okay, well said. Well, I mean, I'll throw in on this question as well. A lot of the work I do is more in the semantic space, and a lot of the reason for work in semantic technologies is so that you can have agreement across different business units or across different partner relationships, or some agreement within a sector that allows for reasonable audits, things like that. And the two of the findings, of course, we have over, ever since like 1998, two of the real findings there are, number one, standards are sort of inherently reactionary. It takes a while for them to happen. So if you ever want to put them in front of your process, be aware that means your process won't happen for months or years. So there is this inherent trade-off between trying to impose standards and trying to be agile. The other thing too is just the notion of late binding. And how important it is to be able to do some sort of data representation with late semantic binding, and really think more in terms of like a latent model, if you will, because there are many reasons for having semantic overlays. They may not fit all the business use cases that you have. So these are some things that were learned the hard way in W3C and others over the past 20 or 25 years. Alrighty, let's see if there's other questions coming. I definitely have more questions too, but anything from the audience? And we have, okay, so we have 4 more minutes in our session here. Let me throw out a question across. What are some business use cases where a lakehouse architecture still isn't quite satisfying the requirements that you have. So just real quick, can you name a use case where this breaks? Adri, can I throw that to you?
Yes, certainly. So some of the use cases are, again, from a machine learning standpoint, or you might say data science standpoint, they don't require the compute and storage, the closeness. That's, it's not very processing heavy per se. Essentially, again, it's the modalities is driven by use cases. So what's the business objective? And then if you see in insurance business, we are doing a lot of forecasting. Maybe time series sort of databases is better. And then if you look into digital risk analytics, which cyber risk analytics, we are looking into hot data. Essentially, we are looking into the ability to access streaming data in a way which is very close to its generation point. I think in that category, Lakehouse doesn't make sense. And then on the other side, if you're looking into the other aspect is feature stores. If you're really processing image data, which we have in some cases, which are to improve the operational effectiveness of, let's say, a domain or process, in that Lakehouse wouldn't help. We need to really cobble up our own system. And that means you have feature stores for image data sets. And you've got modalities around feature store, around essentially also the underlying storage in disk space. So that's where I see Lakehouse maybe not very helpful.
Anjali, I'll turn over to you. How about some specifics where this kind of architecture isn't indicated?
I think most of the times where I've seen it's a bit of an overkill is when you don't really have as much big data as you think you do, or the data sources aren't as heterogeneous as you think they are. I think a lot of the teams sort of want to jump on the latest and greatest. And rightly so, I think, but it can be an overkill, and the implementation costs, the OpEx investments that are required to really enable and derive a lot of value from something like a Lakehouse, those are lacking. And what they end up finding is that they're defaulting to their standard warehouse. And then it becomes a case of, well, this is just another buzzword. It doesn't work. I don't know why we have it. So I think, a lot of it depends, I think, as Adri said, on use cases. Vast majority of the organizations tend to use very structured data, I think. A lot of time series analysis is and image analysis is sort of where I've done a lot of my work, and in those situations, Lakehouses aren't really as useful as they could be.
Very good, thank you. Tom, how about some cases where you've seen that?
Yeah, like active data warehousing. That's something that Teradata kind of coined, and there's a large package company that delivers packages every day. You've probably heard of them. They're a good example of it. It's thousands and thousands and thousands of updates, and every minute that goes by. And to me, that's not really a data warehouse use case. But those kind of active data warehousing, we're doing a whole ton of updates and that type of stuff. I don't think that's there yet. Streaming is great for a data lake, but those type of really interactions are
wonderful. Thank you. Alrighty. Thank you very much, Anjali, Adri, Tom. Thank you very much for your insights today.